My dear friends, welcome back to B-Spice. In this session, we'll continue with HVAC, heating, ventilation, and air conditioning. Ventilating and air conditioning. So control basics. So we are going to talk about the controls, HVAC controls basics. Okay, right. So HVAC controls. In simplest term, control is defined as starting, stopping, or regulation of heating, ventilating, and air conditioning. Friends, here we are not talking about the DCS. We are talking about HVAC controls. So the controls basics all pertinent to HVAC. Okay. So yes, so in a simplest term, the control is defined as starting, stopping, or regulation of heating, ventilating, and air conditioning system. So controlling HVAC involves three steps. Very simple. Measure a variable and collect data. Yes, nothing wrong. I mean new. Then process the data with other information. Yes. Then cause a control action. As simple as that. Okay. So above three functions are achieved, of course, via sensor and controller and control device. As simple as that, right? Okay. What are all the elements of control system? HVAC control system from the simplest room thermostat, you would have seen, right? Thermostat to the most complicated computerized control has four basic elements. One is, of course, the sensor. It measures the actual value of the control variables such as temperature, humidity, or flow with respect to HVAC. And we are talking about HVAC and provides information to the controller. Then the controller receives the input from the sensor, processes the input, then produces intelligent output for the controlled device. Right. So controlled device act to modify the controlled variable as directed by the controller. Then of course the source of energy. This is needed to power the control system. Control system use either a pneumatic or electric power supply. So these are the elements, very basic things. Okay. Okay. Now, basic control rules for room heating. And let us talk discuss with this example. See, thermostat assembly contains both a sensor and controller, right? So here we are talking about the room temperature control. Okay, this is your room thermostat incorporating a single element and controller. And you have this, actuator, wall actuator or control device. Okay, this is your radiator, right? So thermostat assembly contains both sensor and controller, right? Okay, here, right here. So the purpose of this control loop is to maintain the controlled variable. What is that controlled variable here? Room temperature, of course, to some desired value called a set point, right? So heat energy necessary to accomplish the heating, okay, is provided by this guy, a radiator, okay, and the controlled devices, this one, controlled devices is a two-way motorized or solenoid valve which controls the flow, okay, controls the flow of hot water to the radiator, as simple as that, okay. So this is the basic control loop for room heating, okay, right. So now let us talk about them. I just explained how the thermostat is functioning, basic control loop for room heating. So now we'll talk about the theory of controls here. So one is, of course, open loop system is a system with no feedback. There is no way to monitor if the control system is working, whether is the control system is working effectively. Okay. And if you can see here front, this is your time and this is your temperature. And this is your, switch, the function, right? Yes, open loop function. So it's just switched off, then on, here again off, then on, like that. It's cycling actually. So you can see the, the bandwidth and also the time between the cycling, all this. So in an open loop, the controller may operate an actuator or a switch and is often done by the timer, right? Based on the time. So consider a case of an oven. Okay, this is the one. So if the required temperature inside the oven is achieved by a switching on and off a heating element. Okay, so this is known as a sequence or open control loop. So the timer is set by the operator, which operates the electrical circuit to the electric heating element. So that is how it works here. Okay, but here I just want to tell you, once the oven reaches the desired temperature, okay, so the timer will close the switch so that the temperature inside the oven modulates about a set point. So for oven to maintain a constant temperature, the element is switched on and off by a preset timing device which opens or closes the switch by a cam-driven device. So the resultant temperature inside the oven is not really constant, but varies due to a lag in achieving the steady state conditions. Okay. So here, if you see here, friends, this is your bandwidth. I'm going to explain that with the help of another example. So for more control, it would be best to keep the bandwidth between on and off here, right? On and off, right? As narrow as possible. Okay. So too much of switching will wear out the switch contact, especially if there is arcing across the switch contact. So it is evident that there is a relationship between switching time or switching cycle time and how often the temperature inside the oven is at the desired value. So open loop control, but with reduced switching time is shown here. This is what. So open loop control, but with the reduced switching time. So this also can be done. So that's why that's what I want to update you the theory of controls with respect to HVAC. Okay. So oven temperature is more likely to be at or near the set point. Okay. So these type of controls are not suitable for air conditioning and refrigeration system because it does not provide the facility of comparing parameters to be controlled. So here we are talking only about the open loop. Okay. This is just for example. So this is not suitable for air conditioning and refrigeration. Okay. So then which is suitable? Let's see. Closed loop system is suitable. So if the oven in the example had a temperature measuring device and temperature inside was continually being compared with the desired temperature, then this information could be used to adjust the amount of heat input to the electric element. So in the closed system, the controller responds to error in control variable. So a comparison of sensed parameters is made with respect to the set parameter and accordingly the corresponding signals shall be generated. So basically HVAC or typically of closed loops. So closed loop can be broadly classified into two categories. Friends, again, you may be a master in DCS. Okay, you may be a master in DCS control. We are talking about HVAC. Okay, so this guy is into two categories, two position control and continuous control. So this is the simple theory about the closed loop. I mean, in the HVAC. Now, I'm going to explain this with the help of I'm going to explain this closed loop with the help of a temperature control of space heat. Okay. Again, this is your thermostat, this is your radiator, and this is your two-port fan. Okay. So here the room is heated by a hot water radiator, right? So what are all the control elements here? Of course, the sensor, which is the thermostat here, and of course the controller. Okay, here both are here. And you have this control device, valve actuator or a valve actually here. Okay. So here the controlled variable, the air temperature is what we need to be controlled. So by varying the amount of hot water, okay, passing through the valve, the amount of heat being distributed to the room is controlled. Okay. You got it, friends? Right. So maybe I'll explain a bit more with the help of a sequence. Okay. So the desired value or set point is adjusted with the knob on the front of the thermostat. So here this is your thermostat, right? So temperature sensor, this guy measures the actual, value, right? Actual value and sends the signal back along the feedback path to the comparing device here, right? So this is your comparison device. So comparison device actually compares the value, okay, of temperature, okay, right, at the sensor to that of the desired value, that is the set point on the controller, right? Okay. To add on further, the difference between the desired value and the measured value is known as the error signal, right? So the error signal is fed into the controller as low voltage, like 10 volt to the actuator. Right. So the control device, which is an actuator on the two-port valve, okay, reacts to the impulse received from the controller, okay, and varies the flow, okay, and varies the flow of the hot water. So that is the point here. Okay. This guy varies the flow, okay, right, of the hot water. So this in turn changes the condition of space or the process to the desired value. That's it, friends. Very simple. So this type of control is called modulated control because the control elements are constantly changing the signal from comparison device to maintain a near constant temperature in the room, even though inside and outside condition may vary. Yeah, this is though actually. Yeah, even though the inside and outside condition may vary. So this is all about the open loop, closed loop, friends. This is the theory of control. So now, um, this is the simple control basic involved in the HVAC. The next, I'm going to talk about the types of controls in the next video. Okay. So once again, I request all of you to show your support. Of course, for my first video on the fundas, HVAC fundas, not much of a support. So yeah, I'm requesting to support this initiative. This HVAC is also important. It is not that like we should get away with this. This is also equally important, friends. Okay, take care. Bye bye.